Welcome back, welcome back, welcome back. I'm Miss Lisa, and this is my YouTube channel where we talk about everything that I want to, science and math related. And right now we are going to do some physics problems that have to do with sound. So if you are doing this as a class and following along in your book, it's chapter 15. But if you don't have to take the class to learn about the math of sound. So we're going to be doing some problems in our TI-84 graphing calculators, but you could use a different calculator if you want. And this is how we do physics problems. What makes physics problems hard? They're word problems. What makes word problems hard? The word. So what do we want to get rid of? That's right, the words. So read along to yourself, or you can read out loud. I'm not here to judge while I read out loud. It says, a sound wave has a frequency of 261.6 hertz. So that's our first number. So we go down and we write curly F. Frequency is 261.6 hertz. So we got rid of all those words. We only care about the numbers. What is the wavelength? Okay, so now we have a question word. We also write down if we get to question words. So wavelength is what we don't know. Wavelength question mark. Of this sound traveling in air at 343 meters per second. Meters per second, that's the speed. The symbol for speed we're going to use is the symbol for velocity, and there it is. So now we think, is there a formula that relates frequency, speed, and wavelength? Yes, there is. The book writes it this way. I like it this way. That was the way the book I used to teach out. I've always did it, but we'll do it their way for now. So now what do? We sing the song, substitute. And so underneath the V, we write 343. Underneath the lambda symbol, that's our variable, so we leave it the symbol. And underneath frequency, we write the frequency. Then we say, why is lambda not alone? Well, because it's being multiplied. When you have a letter next to a number, it's multiplied by 261.6. And what's the opposite of multiply? Divide. Well, you do to one side, you do to the other, and the answer is 1.31 meters is the wavelength. Now, I can show you how to do that on your calculator, but you probably don't need it. It's just dividing. That's pretty simple. We didn't need our calculator special for that, so I'm not going to show you. All right, next problem. That was easy. So there you can see the Doppler effect thing I talked about. There's people playing musical instruments. Those are the things that hurt your hearing. Okay, there's the lab we're not doing. Okay, keep moving here. Here are musical instruments. Talk about how different things vibrate in the musical instrument. Okay, here's problem number 2. Measuring sound velocity. Okay, so it says a tuning fork, that's that thing that vibrates with the sound. And they're made to vibrate. They have different points of resonance, so they vibrate at different notes. Okay, a tuning fork with a frequency of 392 hertz. Okay, so that's our first number. Hertz is a frequency, so we write that down. F equals 392 hertz. Okay, is found to cause resonance in an air column at 21 centimeters and at 65.3 centimeters. So these are lengths. So length 1 is 21 centimeters, and length 2 is 65.3 centimeters. The air temperature is 27 degrees. That might be important, so we write it down. Temperature equals 27 degrees. We just want to get rid of all the words and just have a nice little column of numbers, because those we can put in our calculator, and that's easy. Find the velocity. So velocity, speed is what we know, in sound at the air at that temperature. Okay, so the first thing we have to do is we need to know the change in the wavelength. Remember, triangle means change. So how you do that is length 2 minus length 1. 65.3 minus 21 is 44.3. Okay, now we have this formula that the change in length equals 1/2 lambda. So we will need to find lambda, so we can put in that to get it by itself, we would multiply both sides by 2. These 2's cancel out, and 2 times the change in length is equal to the wavelength, and it's 88.6. But that's not what they asked for. They didn't ask for change in length, and they didn't ask for the wavelength, but all of this is so that we can use this. Speed equals wavelength times frequency. And we have frequency, and now we have wavelength. So we can multiply them and dun-dun-dun, there's the answer. All right, let's see if we had any more problems in here. I think that was it. I think it's very low math. Oh, nope, here we have another one. Example problem number 3, okay? A 442 hertz tuning fork and a 444 hertz tuning fork are struck simultaneously. What beat of frequency will be produced? Well, so here's our first frequency, there's our second one, and we need the change in frequency will give us the beat. And so we do frequency 2 minus frequency 1, and it's 2 hertz, okay? And you can read more about what that means musically. But it is an oscillation called the beat. All right, I think that's all of our math. That's all of our math. So that's what you'll be doing for your homework. And come back next time and we will talk more about light. We talked a little bit about it when we first talked about wavelengths, but we're going to get more into light. There's a lot more about light. Light's fun. All right, it's really got more than sound in the physics books. In reality, they're both important. All right, so like, share, and subscribe, and I'll see you next time.